In today's Daily Dose of Math, we are doing a task from a pretend Math 4151 algebraic modeling exam. The task is one of the big questions where they expect you to do a series of steps that will lead you to the answer. They don't want it to be too easy. Here we have everybody in a city qualified for a loan to start a business. Does the data indicate that we will have 1,000 new businesses within 1.5 years? And we have a table of values that is counting by months and only goes up to 6 months. So this table doesn't go far enough for us to directly answer the question. The first thing I want to do when I'm answering this question is draw a graph, because that's a way of analyzing the situation. I'm being able to see the patterns better because I'll have the pattern in the table to look at, but I'll also have a pattern in the graph to look at. So I'm going to start by drawing my graph. I don't see any negative numbers here, so I'm not going to show much of the other 3 quadrants, just the top right quadrant mainly. And I want to make sure that these points will fit. So I have to scale. Along the x-axis I just have from 1 through 6. So I'm going to put 10 here, and then 5 halfway. And I have scaled my x-axis so these numbers will fit. But the y-axis, the numbers go all the way up to 72. So I need to scale differently. I'll put 100 here, and then 50. And now we can see what we're doing to be able to draw this graph. We have the point 1, 2, which is going to be quite close to the x-axis. 2, 8, 3, 18. 432, 550, so the 550 is easy to see with the scaling. 432, and then 672 is going to be about here. So right now, the way this is graphed, it's kind of hard to tell what type of function it is. It could be linear. It seems a little bit curvy. Maybe it's the right half of a parabola and it's quadratic. Maybe it's an exponential. I don't know. But I still have a little bit more to look at in order to make my decisions. I'm going to draw a curve, and I think it's not linear, so I'm going to make my curve a little bit curvy. But now the next step for me is to do tests to see which type of function this is. I will point out that if we wanted to draw this very carefully and scale it so that it goes up past 18 on the x-axis, we might be able to read an answer off of our graph. It wouldn't be very accurate, but it is a way of answering the question, just not the most efficient way. So now I'm going to do the tests with the table of values in order to figure out what type of function I have. And I'm going to start with the test for linear, the constant difference. 8 minus 2 equals 6. 18 minus 8 equals 10. I'm already failing this test. 32 minus 18 is 14. 50 minus 32 is 18. Well, I only have one more point, so I may as well do the last one. 72 minus 50 equals 22. The next thing I'm going to do is the second difference to see if it's quadratic. I already think it's not linear. In fact, I can even say so. Not linear. Second difference, I'm doing the same thing, but I'm using the answers from the constant difference, the first difference. 10 minus 6 equals 4. 14 minus 10 equals 4. Oh, it's starting to look like a second difference. 18 minus 14 equals 4. 22 minus 18 equals 4. And I can see that it is quadratic. But just because this video wants to show students all the techniques that they might need in the exam question, I'm going to go ahead and do the constant ratio test to see if it's exponential, expecting the answer to be no. For that, I'm not using the answers from the first difference. I'm using the original y coordinates and I'm doing 8 divided by 2, and it gives me 4. 18 divided by 8, (2.25). I'm not getting a constant ratio. 32 divided by 18, 1.78. So I can say it's not exponential. Now I've done tests to see what type of function it is, and I've done a graph so that I can see the patterns a little better. Because I've decided it's quadratic, I want to do some quadratic math now. I want to find the equation, and I'm using the form y equals ax squared. So I just need to figure out what my a is. And I'll do that by plugging in one of the points. I'm going to just choose any of the points instead of trying to pick the first point, the easiest looking one. I'll try 432. 32 equals a times 4 squared. 4 squared is 16, so 32 equals 16a. And we isolate our a, and we get a equals 2. Therefore, our equation is y equals 2x squared. Now, to answer the question, I want to plug 1.5 years. But I have to realize that's 18 months. So I'm plugging x equals 18 in here. Y equals 2 times 18 squared, which is 2 times 324, which is 648. So after 18 months, we are likely to have 648 new businesses, and therefore the answer to the question is no. We will only have 648. Now, the question didn't really ask, is it likely we'll ever get to 1,000 new businesses? But the answer to that question would be, well, yes. These numbers are increasing quite quickly. We are getting pretty close to 1,000 after only 18 months. So if we were to plug in 19, 20, 21, we might find a value that is more than 1,000. But this question just said, in 1.5 years, will we have 1,000 new businesses? The answer to that question is no. So when you do a task, you want to do an analysis of the situation. Drawing a graph is a good way to start that. Doing tests to see which function you have justifies the type of math you end up doing to find an equation, so that you're not just randomly doing this, you're showing why you think this is the right thing to do. And then you use the equation to answer the question, and you're careful to include a unit of measure in your answer, which I haven't done. So I will write the word businesses here, so that my answer is more complete. That's today's Daily Dose of Math. Please like, subscribe, and share.